So first and foremost, beginning of a section, always like to go over our objectives. What is the goal for today? The goal for section 4.5 is to use and apply properties of isosceles triangles. Okay, sorry, Jamboard's just loading over here. All right, section 4.5, objectives. To use and apply the properties of isosceles triangles. All right, very important. All of us must know what we're saying when we say isosceles triangle. Luigi, Nazari, George, Heidi, you guys need to join with your video. Okay. Naomi, if your video is fixed, you need to join with your video as well. Okay. That's part of our attendance. Okay. If you need help, Naomi, if you need help with your video, you need to speak with me so that I can help you resolve this issue. Okay, because this is your attendance. All right. So, objective, to use and apply the properties of isosceles triangles. Luigi, what do we mean when we say isosceles?
Two of the sides are parallel and one of them isn't.
Okay. I think I know what you mean. Not parallel. Two of the sides are what, Luigi?
They're congruent, I think.
Very good. Two sides are congruent, all right? And particularly, what that would also mean is generally those two angles are congruent, which means this is the isolated angle. All right? There's an isolated angle or an angle that is different than the other two. Okay? So, understanding, we have three theorems. Okay? We've got theorem 4.3, which says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. Okay? So it says if those two sides are congruent, if two sides are congruent, then opposite angles are congruent. All right? That's what I'm showing here. If the sides are congruent, then the angles are congruent. Okay? All right. Next up, we've got theorem 4.4. All right, the converse of the isosceles triangle theorem, if two angles of a triangle are congruent, then the sides opposite the angles are congruent. Okay? This is the iso triangle theorem, right? That's our nickname. This is the converse of the isosceles triangle theorem, which says basically the same thing, but the converse. If two angles are congruent, then opposite sides are congruent as well. Okay? And then lastly, theorem 4.5 says the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. Okay? So, what does this say? The bisector AC, segment AC, is perpendicular to BD, to segment BD. Okay? Says that if The bisector is the bisector of the vertex angle, that is the isolated angle, is perpendicular to the base of that triangle. All right? So, using these three, if you look, you have the proof of the isosceles triangle theorem, okay? And they do that by creating two right triangles, okay? However, more importantly, we want to use the isosceles theorems looking at example number 1. All right, example number 1. Explain why each statement is true. Angle WVS, okay, is congruent to angle S, okay, and it says WV is congruent to WS, so angle WVS is congruent to angle S by the isosceles triangle theorem, okay. So, really quick, I want you guys to understand what it is that they've actually given us. So they have this kind of complex looking triangle thing. Okay? They've got here, here, right? And the basically, what they've given you is that WV is congruent to WS. Okay? What is that? What are those lines? What it's saying is that this line is congruent to this line. Okay? That's what this is saying. Okay? And so, the isosceles triangle theorem says that we can say, therefore, okay, if you don't know what 3 dots means, this means, therefore, don't forget that, 3 dots means therefore, angle WVS is congruent to angle S, okay, and the reason is because of the isosceles triangle theorem, which says that if 2 sides are congruent, then the angles opposite those sides are congruent. So therefore, this angle is congruent to this angle, which is angle S. Okay? Example 2 is, again, on page 229. All right? Find the value of y. So now we are going to use the isosceles triangle theorem to solve this equation, okay? So we have 2 sides that are congruent, okay? We have 63 right here. We've been given that these 2 are congruent, and the reason why is because definition of an angle bisector, okay? Because it's the bisector, okay? Now we also know that it makes a perpendicular line, which means these are 90 degrees, okay? Heidi, what's another piece of information you could give? Because you're given the fact that this is 63 degrees, okay, let's label our triangle MNOL. What other angle is 63, Heidi?
The one on the other side.
What?
The one on the other side.
Oh, just give me a letter.
N.
Angle N. Good. Right? This angle well, let's just say this angle right here is 63, okay? And we know that because of the isosceles triangle theorem, all right? So the question is, find the value of y. So we have 63 plus 90 plus y equals 180, because every triangle is 180 degrees. So we add these two together to get 153 plus y equals 180, minus 153, minus 153, y equals 27 degrees. Okay? Awesome. So hopefully you guys are understanding the isosceles triangle theorem. Okay? Now, when we talk about a corollary, okay? A corollary, something that we're going to learn about, and you can see it on the bottom of page 229. A corollary is a statement that follows immediately from a theorem. Corollaries to isosceles triangle theorem and its converse appear on the next page. Okay? So, we have corollary to theorem 4.3, okay? More specifically, corollary to I like corollary to isosceles triangle theorem, okay? I like that better because it tells us what it's about and you don't have to memorize a bunch of random numbers, okay? So, it says, if a triangle is equilateral, then the triangle is equiangular, okay? All right? And then corollary to theorem 4.4, if the triangle is equiangular, then the triangle is equilateral, okay? Right, so this is the corollary to the converse of the isosceles triangle theorem, which says if a triangle is equiangular, then the triangle is equilateral. Okay? Again, this would be a better name for it, because the name defines what it's about. All right? So, how could we use it? Well, a landscaper uses rectangles and equilateral triangles for path around the hexagonal garden. Find the value of x. All right? So, in a rectangle, an angle measure is 90 degrees. Okay? So, if we know that all the rectangles are 90 degrees. Let's go ahead and draw a picture of this. Okay, and at each one of these, you've got a 90-degree rectangle. Of course, my drawing isn't perfect. And we want to know what the value of x is. Okay, so if we can find the value, right, we know that this is 90 degrees and this is 90 degrees. Actually, that's not the best example because that looks like it's vertical angles, which it's not. Okay, so we've got 90 degrees and 90 degrees, all right? Rectangles and equilateral triangles around the path, right? We need to find the value of x. Okay? And if you look in a rectangle, the angle measure is 90. In an equilateral triangle, the angle measure is 60. Okay? How do you know that? Well, if you have a triangle and they're all the same, you can say x, x, and x. 3x equals 180 over 3 over 3. X equals 60 degrees in an equilateral triangle. Every equilateral triangle will be 60 degrees on each side. Sorry, I'm just going to reload the Jamboard because it's lagging. All right, there we go. So we have x equals 60 for this equilateral triangle. Of course, that's not this x in here. Okay, so that's saying that this is 60 degrees. This is 90 degrees. That's 90 degrees. Okay? And all in all the way around would be 360 degrees. Okay? Now, let me explain that. I'm going to take this and I'm going to expand it. Okay? We've got our value for x. We've got our triangle, which is 60 degrees. We've got two 45-degree angles, which of course are 90 degrees and 90 degrees. Okay? And if you basically call this a circle, okay, which is 360 degrees, you can say 90 plus 90 plus 60 plus x equals 360. So we subtract 180 plus 60 minus 240 minus 240, and you get x equals 120 degrees. Okay? Now, it looks like an equilateral, an equiangular, or a regular polygon, so you basically could just say n minus 2 divided by 6, okay? In which case you would get n minus 2 times 180 divided by 6, where you'd get 4 times 180, which would be 720, divided by 6, which would be 120, all right? What is the measure of each angle at each outside corner of the path, okay? What is the measure of each angle, of the angle at each outside corner of the path? All right? And the answer to that would be 150. What are we talking about? Okay? You have 90 plus 60 gives you the outside corner of the path, and that angle, this angle right here, is 150. Okay? 150 is that angle. If you were to say this angle right here, 150 degrees. All right? That's not really necessary, but that was that little quick check question down at the bottom. All right. For the most part, the basics of section 4.5 is equilateral triangle theorems. All right? Now, I'm going to do maybe 2 from the homework, and then I'm going to have you guys do 2 from the homework before we jump directly into section 4.6, which is right triangles. Okay? So, number 2, on page 230, number 2, there's a triangle, lots of fun complexities, like this, VUT, W, X, Y, and we have all right, so the question is UT, number 2, says UT is congruent to what which is also congruent to yx. Okay? So we're saying that ut here, let's just color, it says that this ut is congruent to a unknown, which is also congruent to yx. Now, I want you guys to understand what's happening here. They are trying to do the transitive property and show you now, instead of doing the transitive property, they're asking you what is the middle equivalence in this transitive property. And the answer is, you have to say ut is congruent to uw. This is uw. And how can you say that? Well, the reason why you can say ut is congruent to uw is because if the angles are congruent, then the sides are congruent. So this would be the converse of the isosceles triangle theorem. Okay? Then we can say this is congruent to yx, right? And if I asked you why, the answer would be it's given. In the triangle, they gave you these two sides are congruent. Okay, again, my triangle, my drawing isn't drawn to scale, but hopefully you guys can see it in your book and you can get the gist. Okay, continuing on, looking at question, again, we're still on page 230. Page 230, question number, let's do question number 7. All right, so we've got a triangle. X, 52y. All right, and so we want to find x and y. All right, remember, when it hits, it makes a 90-degree angle. Okay, so we can say 52 plus 90 degrees plus x degrees equals 180. Okay, so we're taking this angle, and x to equal 180. All right, so we can say 90 plus 152 is minus 142. X equals 38. Okay, now we can also say, by the definition of a bisector, y equals 4 because of the definition of a bisector. All right, I'm going to be giving you question numbers for you guys to do. I want you to work on them. I'm going to create an assignment at the end of class. You're going to take a picture and submit it to the assignment. Okay? So I want everybody to do page 290. Sorry, page 230. Number 4. And number 5. Go ahead and do it now. I'm going to give you about 5 minutes. I'm going to step out. I'll be back in 2 minutes. Any questions? All right, so you guys should be finished with those two. And we are going to move to page 231. Okay?
You didn't upload an assignment for us to attach an image.
Okay, you gotta listen, Luigi. I know maybe it's just your internet. At the end of class, I'm gonna create an assignment and you're gonna upload all of your work. Okay, because we're still gonna do more. Okay?
Thanks. Yeah, I think it's my Wi-Fi connection.
That's fine. That's fine. So, number 10, on page 231, the measure of angle L equals 58. Then the measure of angle LKJ equals what? So you've got boom, 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 boom. Okay. Which gives us, we know 90, 90. And the question is, what is LKJ if measure of angle L is 58? Okay, so let's draw down J, M, L, K. Now pay very close attention. So they said the measure of angle L here is 58 degrees. So we know that this one is also 58 degrees. So the question is, then what is LKJ? LKJ, that's this big angle. Okay? Now, how do we do this? Well, 58 plus 58 plus the measure of angle LKJ equals 180. Sorry, it's not loading. Give me 1 second. I'm going to There we go. Okay. All right, so adding this angle plus this angle plus this big angle gives us 180. Okay, so 58 plus 58 is 116 plus the measure of angle LKJ equals 180 minus 116 minus 116. Measure of angle excuse me, LKJ is what is that? 64. 64. Okay? Again, you guys might be looking at this and saying, well, how are we supposed to know this? Well, understanding when you see a triangle with these symbols, okay, that tells you you're dealing with an isosceles triangle. So that means the opposite angle of that bigger triangle, those opposite angles are congruent simply by the isosceles triangle theorem. Okay? All right, last one that we are going to do of this is question number 15, page 231, number 15. All right, let's get a little drawing of it. All right, here's our triangle, and we need to supply the missing parts to this, okay? So begin with isosceles triangle HKJ, okay? So we know that we have an isosceles triangle. How do we know we have an isosceles triangle? Because two sides are congruent, okay? So we know that it's an isosceles triangle, all right? We would then draw that bisector, okay? So what is given to us is KH is congruent to KJ, and we're going to use KH is congruent to KJ, all right, and secondly, HJ, KM bisects HJ. Okay? So they wanted you to actually put in KM, right? They're looking for you to put KM and call it KM as the bisector, right? So you've got to draw that line in to say KM bisects HJ. All right, now let's go ahead and get to what we want to prove. Prove that angle H is congruent to angle J. All right, now we cannot do, we're trying to prove the isosceles triangle theorem, so you can't just say the isosceles triangle theorem, unfortunately. All right, so we got our statements and our reasons. Now they give you all the statements, right? They say KM bisects HJ, okay? And we simply did that, right? We constructed it, okay? They told us to draw it, all right? It's constructed, or it's shown on the image, okay? Next, HM is equivalent to JM. Congruent to JM. All right? And how can you say HM is congruent to JM? That would just simply be the definition of a bisector. Now we could say segment bisector. Okay. 3, KH is congruent to KJ, okay? And as we know that was given to us right here. 4, KM is congruent to KM. What are we saying here? We're saying that that line is congruent to itself. Anytime a line is congruent or an angle is congruent to itself, we call this the reflexive property. 5, triangle KHM is now congruent to triangle KJM. And the reasoning would be SSS, because we've got side, side, and side. So we know now the two triangles are congruent. Now that the two triangles are congruent, you can say any parts of the triangles are congruent. So you can say H is congruent to angle J because of CPC TC. Congruent parts of congruent triangles are congruent. So now we can say angle H is congruent to angle J because of CPC TC. Okay? All right. We are moving on from section 4.5 into section 4.6, talking about congruent right triangles. The objective in section 4.6 is to prove triangles congruent using the HL which is the hypotenuse leg theorem. Okay? 4.6 objectives. Prove triangle congruence by the HL theorem. Okay, HL is hypotenuse leg. Okay, so what is this? Okay, what is hypotenuse and legs? Okay, now in a right triangle, very important. Everybody must pay attention and understand this terminology. Okay. If you don't know the terminology, you have no chance in this. Okay. This is called the hypotenuse. Okay. This is a leg. This is also a leg. Okay? Now, what is very important is this is only for right triangles, right? But also, if we call this theta, okay? This is the Greek letter theta, okay? If this is angle theta, this side is called the opposite side, and this side is called the adjacent side. Okay? Now, very important, in the same triangle, if this is theta, this is the opposite, and this is the adjacent. Okay? The hypotenuse is always the hypotenuse. All right? So, with that information, we can move into learning the HL theorem, Theorem 4.6. Our terminology for it will be the HL theorem, the hypotenuse leg theorem. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay? If the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. Okay? So, if we can prove that it is a right triangle, if we can prove that the hypotenuse and the leg of one are congruent to the hypotenuse and leg of another, then we can say that the two are congruent. Okay? So, I'm going to jump to example number 2. We have CD is congruent to EA, and AD is perpendicular bisector is a perpendicular bisector of CE. All right, everyone, very important to understand in terms of vocabulary, right? If you don't know what perpendicular from, I don't know if it was chapter 1, if you don't know what a bisector is, okay, you're going to be in trouble. The perpendicular lines, they look like this, and they always make right angles, okay, at the intersection. A bisector splits equally. Splits an angle equally, splits a segment equally. Okay, so AD, that segment is a perpendicular segment bisector of CE. All right, so let's go ahead and give ourselves a little bit of a drawing. All right, so we've got A, B, C, D, E. All right, so AD, right? AD is a perpendicular, which tells us that we've got 90-degree angles here and here. Bisector of CE, which tells us that CB will be congruent to EB. Okay? So, let's just start throwing out some information. Some stuff that we know. Okay? We know angle CBD is a right angle. We know angle EBA is a right angle because of definition of perpendicular lines. Okay? We also know that CB is congruent to EB. Why? Because definition of segment bisector. Okay? Now, all we need is that CD is congruent to EA. CD, the hypotenuse here, is congruent to EA. CD congruent to EA. And the reason is that that was given to us. So now we have a hypotenuse and we have EB and CB. We have a leg. So we can say that the two triangles are congruent. All right? We can say triangle, let's use black. We can say triangle AEB is congruent to triangle DCB because of the HL theorem. Hypotenuse leg theorem. All right? That is using the hypotenuse leg theorem. Also, using the hypotenuse leg theorem, example 3, WJ is congruent to KZ, angle W, and angle K are right angles. Here's our drawing. WZKJ. Whoops. All right, here we have it. All right, Nazari, how can we prove that the two hypotenuses are congruent?
Well, because there's, let's see. Well, we can see that W and K are right angles. And since those are congruent, then the hypotenuse, and also the reflexive property, because the hypotenuse is the line in the middle, and since JZ equals JZ, it would be congruent.
All right,
Or not congruent.
remember, whenever you have two triangles or two shapes that share a side, many times the proof is going to ask you to use the reflexive property. Okay, so very good. What you said before at the beginning was actually not true. You can't say that they're congruent because the angles are right angles or because the sides are congruent. The only way you can say JZ is congruent to JZ is the reflexive property.
Yeah,
Okay.
that's why I changed my answer.
Yeah, no, it's good. You caught yourself. But I just wanted to clarify for other students in case. But very, very good work there. Okay? Now, they've also given to us that WJ and KZ, they've already given to us that this one is congruent to this one. Okay? So now we have a hypotenuse and a leg, right? We're already done. Okay? We have the given, which is their right angles. The second one is that they're both right triangles, because if they're right angles, then they're a right triangle if there's a right angle in them. So that would be just the definition of a right triangle. JZ congruent to JZ, reflexive property. WJ congruent to KZ, that was given to us. And then now because you have the hypotenuse and a leg, you can say that triangle JWZ is congruent to ZKJ by the hypotenuse leg theorem. Okay? All right. Number 1 on page 237. All right, I'm going to show you guys in a short paragraph. Write a short paragraph to explain why the two triangles are congruent. Okay? So, here we have a 6 and a 6, a 10 and a 10, and they're both right triangles. So we can say that triangle ABC is congruent to triangle DEF by the hypotenuse leg theorem. Okay, both triangles are right triangles. AC is congruent to DF. Okay, and CB is congruent to FE. Okay, how would we do that? Well, if we simply just started off by saying CB, change my color real quick. CB is equal to 6. If we were writing a paragraph, we might say segment CB is equal to 6, and segment FE is equal to 6. Therefore, CB is congruent to FE by the transitive property of congruence. Okay. Then we can say the same thing of AC, segment AC is equal to 10, and segment FD, it would be DF. I hope I didn't mess that up on the other one. CB, it should be FE. Okay, good. Segment DF is equal to 10. Okay. And therefore, AC is congruent to DF by the transitive property of congruence. Okay? Then we can say, because we have a hypotenuse and a leg, we can say angle B and angle E are right angles. Therefore, triangle ABC and triangle DEF are right triangles. Okay? Then you can say that triangle ABC is congruent to triangle DEF by the HL theorem. Okay, so basically we're just writing out. Now generally I won't give you guys questions like this on the test or anything like that, but it is important that you guys understand. I basically just separated a statement and reason into different sections, okay? Into 3 different sections. Excuse me. If you look at question number 3, you would need to know that they are right triangles in order that they're right angles in order to prove by the hypotenuse-leg theorem. You need to know that angles are right angles, otherwise you cannot use the hypotenuse-leg theorem. It only works for right angles. Okay? All right. The last question for you guys for your classwork is question number 7 on page 238. All right, it's a proof. Question 7 on page 238. You can go ahead and do it now, or you can do it later, okay? I'm going to upload the assignment. Remember, if you haven't taken your quiz, you need to go ahead and do so. We will be taking a quiz at the start of class tomorrow based on these 2 theorems, the hypotenuse-leg theorem and isosceles triangle theorems. Okay, we'll take a quiz on them tomorrow. I will be uploading the teacher edition. Except for question number 7, you need to do question number 7 and submit it to your classwork. Okay? If there's no other questions, you may be dismissed. I will see you guys tomorrow. Make sure you get question number 7 and everything that you did today. Take pictures of it and upload it to the Google Classroom.